Welcome! In this video, I'd like to show how to solve exponential equations. One method to solve exponential equations is by rewriting both sides of the equation in terms of the same base. First, express both sides of the equation in the same base, and then equate the exponents. Lastly, solve for x. If you cannot make the same base for both sides, then we need to use another method. Step 1. Isolate the exponential and take the log or natural log ln of both sides of the equation. If the base is e, then take the natural log. For other bases, we use log, which has base 10. Step 2. Apply the power rule of log properties. Step 3. Then solve for x to get the solution. Let's start with the first example. First, we need to write both sides of the equation using the same base. Since the left side is expressed in the base 5, we try to express 25 in the base 5 on the right side as well. As you might expect, 25 can be expressed as 5 squared. Now that we have the same base 5 on both sides, we can make each exponent equal each other, which becomes 3x equals 2. Finally, we solve for x. Divide both sides by 3 to get x equals 2/3. For b, again, we begin by rewriting both sides of the equation in the same base. Since the left side is expressed in base 3, we try to express 27 in the base of 3 on the right side. 27 can be written as 3 cubed. Using the power rule of exponential properties to write the right side as 3 to the 9x. Now that we've written both sides in the same base 3, we can equate the exponent as 5x minus 2 equals 9x. Lastly, we solve for x. We move the 9x term from the right side and move the constant negative 2 to the right side to get negative 4x equals 2. Finally, divide both sides by negative 4 to get x equals negative half. Let's try another example. Since we have base e on the left and 3 on the right side, they cannot be matched. However, we can take the logarithm of both sides for this example. As we can see the base e, we take the natural log ln for this. Using the power rule of log properties to express the left side as negative 4x times ln e equals ln of 3. Finally, we solve for x. Since ln e is 1, we can rewrite the equation as negative 4x equals ln of 3. Divide both sides by negative 4 to get x equals negative ln of 3 over 4, or approximately negative 0.275. Let's try a similar question. We have the base 7 on the left side. However, 8 cannot be expressed in the base 7 on the right side. Instead, we can again take the logarithm of both sides for these type of questions. As we have the base 7, we take the log. Please note that log has base 10. Then apply the power rule of log to get the left side as bracket 2x minus 1 times log of 7 equals log of 8. Finally, we solve for x. Divide both sides by log of 7 and we get 2x minus 1 equals log of 8 over log of 7. Move the constant negative 1 to the right side. Then divide all terms by 2 to get the solution as shown. Let's solve one more example. Since we have the exponential functions on both sides, collect all the powers to one side by dividing both sides by e to the 3x. Then cancel e to the 3x to get 8 on the left side. And apply the quotient rule of exponents on the right side to get 2 e to the 2x. Again, divide both sides by 2 to isolate the exponential. We take the logarithm of both sides this time. As we can see the base e, we take the natural log ln for this situation. Using the power rule of log properties, we can rewrite the left side as 2x times ln e equals ln of 4. Last step, we can finally solve for x. Since ln e is 1, we can rewrite the equation as 2x equals ln of 4. Divide both sides by 2 to get x equaled ln of 4 over 2, or approximately 0.693. I hope this video has helped in your understanding of solving exponential equations. Thank you for watching. See you again.